Hello, today we're going to start a new chapter, chapter 5, exponential and logarithmic functions. We're going to do a brief review of exponential and logarithmic functions in 5.1 and 5.2. Let's start from 5.1 exponential functions. The exponential function is defined as f of x equal to b to the x, where b is a positive constant not equal to 1, and it's called the base, and x is in the exponent. If you look at the graphs of exponential functions, there are some common features. First, all the curves lie on the upper half plane of the xy plane. Secondly, all the curves pass through 1 on the y-axis. That means the y-intercept is 1. But depending on the values of b, they have two distinct cases. When the base b is greater than 1, the exponential function increases rapidly. When the base b is from 0 to 1, the curve decreases rapidly. There are some laws for exponents. B to the x times b to the y equals b to the x plus y. B to the x over b to the y is equal to b to the x minus y. B to the x to the y is equal to b to the x times y. A times b to the x is equal to a to the x times b to the x. A over b to the x is equal to a to the x over b to the x. There's a spatial base we call it E. It's called the natural base. It's defined as the limit of 1 plus 1 over n to the n as n approaches infinity. This is an irrational number, and the numerical value of the number is about 2.7182818. The natural base E has important applications in calculus. So that's exponential functions. Now let's talk about logarithmic functions in 5.2. The logarithmic function is the inverse function of the exponential function. That is, for any x greater than 0, if you write y equal to log x to the base b, that means x equal to b to the y. So we define the exponential function y equal to b to the x on the last slide. If you switch x and y, you get the x equal to b to the y, and that defines the inverse function of the exponential function, and we write it as y equal to log x to the base b, and we call it a logarithmic function. Log x to base 10 is usually written as log x, and log x to base e is written as ln x, or natural log. There are some laws for logarithms. Log m times n to base b is equal to log m to base b plus log n to base b. Log m over n to base b is equal to log m to base b minus log n to base b. Log m to the n to base b is equal to n times log m to base b. Log 1 to base b is equal to 0 for any base b. Log b to base b is equal to 1 for any base b. The graphs of exponential function y equal to b to the x, and the its inverse function, logarithm function, y equal to log x to base b, are symmetric with respect to the line y equal to x, as shown in the graph. So that means the x-intercept of the logarithm function is 1, right? And there are two important properties relating exponential and the logarithm functions. B to the log x to base b equal to x, and the log b to the x to base b is equal to x also. And so this is true for all function and its inverse function. So that's the end of today.